Okay, hi and welcome to video notes on writing quadratic functions from a graph. So today what we're going to do is we're going to go ahead and explore how to take information from a graph, and there's not currently one here, and make it back into a function. But before we do that, let's go ahead and talk about then writing an actual function into a graph. So how do we do that? We've done it a few times. So let's start by making a table because we're almost always going to need a table for some fashion. And you'll notice that I've designed my little table a little bit different than I've done in the past. I'd like to do this instead of just an XY table. I'd like to look at it as an XY table with the function in there so I can actually see what my inputs are going into. Again, those are my inputs. And then my outputs are going to come out from putting it inside the function, and that's going to make my outputs, or my y values. In this case, f of x values. Remember, f of x is great for plugging or showing what values we're putting into the function. But before we do that and jump in and graph the whole thing like that, we have a couple techniques to help us graph these quadratic functions if they're in certain forms. Okay, and looking at this form, you'd recognize it as vertex form. And if we're in vertex form, we could probably pull out the vertex, I'm guessing. If we remember, and I'm going to scoot it down because I already wrote it once, remember that h and k are going to give you the values of your vertex. So if you can identify h and k, there's your vertex right away. So let's go ahead and do that. Our vertex here, remember, this is supposed to be a negative. You can see it down here in the left corner, or the right corner here. That's supposed to be a negative. So for this to be positive, it means that my x value is -1, and my vertex is going to be completed with this -4, which is my y value. And it's going to be just as it says. So there's your vertex for this, because that's just a nice little handy trick. If it's in that form, to go ahead and pull it out. So I'm going to go to -1, -4. There's my vertex. Additionally, we get this awesome piece of information. Do you know what it is? I'm going to go ahead and mark it, and then you can say out loud at home what this is. This is, you're correct, the axis of symmetry, and the axis of symmetry for this particular function is x equals -1. It'll always be a vertical line, and remember x equals a number is a vertical line, through whatever the vertex or the x-coordinate of the vertex is. So now that we've got that listed, let's go ahead and start filling in some other points, because one point does not a parabola make. We need a couple more. And also, while we do this, let's be smart about this and remember that there's symmetry to both sides of this. So whatever point we find on the right side of this axis of symmetry, we can duplicate that point on the other side because of symmetry, the equal distance away. So instead of picking 0 and -2, let's just pick 0, 1, and we'll check even 2. So let's put those values in. We're going to check 0, 1, and 2. Now with this new table, which we haven't done a ton of, it's just showing the calculation as we do it. So I would write something like this, f of 0, or I'm evaluating this function right here at 0, that's all that says, and I'm just going to plug in 0 wherever I see x. And I know that's really small, maybe I'll zoom this in really quick here. So I'll zoom that in. So I've got f of 0 equals 2 times the quantity of 0 plus 1 squared minus 4. I think we can do most of that calculation in our head. We'll start inside the parentheses here. 0 plus 1 is 1, squared is 1, and 1 times 2 is 2, and 2 minus 4 is -2. So we get the point 0, -2 right out of there. So let's go to 0. There's my 0 for my x-coordinate, and then down 2. I'm going to get that point right there. Let's use the magic of symmetry then to say, hey, I'm 1 unit on the x-axis over, so I'm going to go ahead and move 1 unit over here, and I get an additional point. And while that looks like I could draw a nice parabolic shape, I'm going to graph a couple more points because I don't know if I've got the end behavior shape of this, how it's moving upwards very well. I could probably be a little more accurate. So let's do a couple more here. So f of 1 then is equal to 2 times 1 plus 1 squared minus 4. Let's do that calculation again. 1 plus 1 is 2, 2 squared is 4, 4 times 2 is 8, 8 minus 4 is positive 4. So we have the point 1, 4. Let's go ahead and plot that down. So I'm going to go to positive 1, which is here, and then I'm going to go up 4, because that's where it's telling me the point is. And so notice it is a very narrow looking parabola. Let's also use our symmetry right here and go 2 units to the left of this line of symmetry. And now we've got quite a bit here to go ahead and graph this. So if I were to graph this, I'm going to sketch down this decreasing side, right, down to the turning point or the vertex. And then I'm going to go ahead and do this other side. You want this to look fairly accurate because you've taken your time to find a whole bunch of points. and make this a nice sketch. Well, that's great. Nice little review of graphing. We've already done that. We'll keep off of the second point here because we know it's going to go off the table. It's going to get much larger. But with that, we notice that we should be able to graph. If we could get the vertex, we could go right back into the vertex form. And the only piece of information that we will have to find is that value there, that 2. Because the x and y we don't need, and the vertex is the 1 and 4. So really there's only one piece of information that we have to find, which is that a. So if we're working backwards, seeing that happen, we're going to go ahead and identify the vertex from our graph. Then we're going to identify one additional point. It could be any point you want. It could be this one, could be this one, could be this one. Just one though. And then we're going to put those pieces in. And let's highlight the pieces that we'll plug in. We'll plug in an x, we'll plug in a y, we'll plug in a k, we'll plug in an h, and the only piece that we'll have left, if we take the vertex and any other point, is a. And as you can guess, what we're going to do is we're going to solve for a. Oh, there it is. We're going to solve for a. And then once we solve for a, we rewrite the equation and we're done. Let's go ahead and see what that looks like then. Here's an example over here on the left for you to review if you need to. I'm not going to talk about that one, but let's do this one here. So here's our parabola. It is our vertex right here. So -1, 0 is our vertex. Let's go ahead and write that down, vertex. It's always nice to label your information as well. Our vertex is -1, 0. I know it's on there, but I'm gathering my information. I need any other additional points, so I'm going to write any point. And that's going to refer to this one here, which is -2, 2. So I've gathered the two pieces of information that I need. So let's plug in our vertex into our vertex form. So let's start by doing that. Y equals work f of x, doesn't matter, a times x. And then I'm going to put in my h value, which is my x coordinate. It's supposed to be negative, so it's opposite looking when it goes in. If it's a -1, it's going to look like a +1. Remember that. Squared plus my k value, which just happens to be 0. Do I really need to write +0 here then? No, I really don't. So now let's plug in our other piece of information. You'll notice the only thing left that we won't know is a, and if we have one equation and one unknown, of course we can solve. So my y value is 2, so I'm going to go ahead and plug in 2 here. 2 equals a, and x is -2, so -2 if you will. Oops, I don't know why I'm putting a comma there. I'm not writing a point. Let's get rid of that. I'm going to go ahead and put +1 squared. Now you'll notice I can solve this pretty easy. Let's clean up the insides here. So 2 equals a, -2 plus 1 is -1. Now we're going to square that. So 2 equals a, and 1 squared is 1, or just a. Hey, look how nice that worked out. It wasn't a difficult task at all. Now we should be able to go ahead and write our vertex form. So here is us writing this equation. Y equals our a value, which is 2, and then x minus our h, which we've already partially written right here, which happens to be a +1 squared, and we don't write +0. And there you go. You just wrote the equation for a vertex form of a quadratic function, or a parabola better known. Something that we need to note, and I wrote up here, but I didn't reference. Ready? This only works, and you can do this with vertex form, which we just did, or factored form if you have the intercepts. So if you've got the intercepts here, then you can write it into factored form. Factored form would look something like this: an a value out in front of your two factors. No, I didn't do that very well. Let's do this here. Your variable minus whatever the first coordinate is, and your variable minus your second coordinate. It's not the vertex. Don't use h and k as vertex. I'd probably call it b and c or something. But you can also do the same thing. I'm not going to show you that, but you can work with factor form. Notice, though, you cannot, no standard form. You can't write an equation for standard form, okay? That's the key. So make that note somewhere. You can't write in standard form. So if you did want to get to standard form, what would you do? You can convert to standard form by just multiplying out the vertex form. Because if this is a linear binomial squared, we'll just distribute, multiply by 2, and we'll be in standard form. So let's see what that looks like then. So I'm going to go ahead and rewrite this. Y equals 2 times x plus 1 squared. I'm going to break up that x plus 1 squared into its two linear binomials, so x plus 1 times x plus 1. You could also use perfect square trinomial pattern to multiply that out. A lot of you don't remember it, so we'll go ahead and expand it manually. X times x then is going to be inside the parentheses, x squared. X times 1 is x. Oops, forgot my square there. And 1 times x is also x, and 1 times 1 is 1. So let's clean that up. We're going to get 2 times x squared plus 2x plus 1, just simplifying these two terms here. And now we're going to go ahead and distribute that 2 to all three terms. So we're going to get y equals 2x squared plus 4x plus 2. And that's what this would look like in standard form. All right, that's how you get to standard form if you're asked to write into standard form. You must go through either vertex or factored form. It's the only way you can get to standard form. You have to go through them. It's a little bypass for you. But let's review everything that we've done today. We looked at graphing from a table, just as a nice little review. We did talk slightly about the axis of symmetry. We know that we have to write into either vertex form or factored form. Taking the vertex in this case in any other point. If we had the factored form, we'd take the two y-intercepts into any other point. But another point is always necessary. That should do it for us today. Thanks for watching, and we'll see you in class.